Hello guys, today I'm going to explain the concept of reduced mass. It is a very popular topic in Newtonian mechanics. Reduced mass is represented by the symbol mu here. It is the effective inertial mass of two-body problem in Newtonian mechanics. Uh, Recently, in the Bohr model and this stuff, you know the Rydberg constant and the wavelength. Uh, they recently discovered that the wavelength and ionization energy differ by approximately 0.1% from the measured value. The Bohr model equation is just as a prediction of these values of wavelength and ionization energy. You can recognize in the equation that the wavelength is depends on the Rydberg constant, and the Rydberg constant depends on the mass. But this mass, they discovered that it is very more efficient to recognize it as the reduced mass instead of the mass itself. You know the Rydberg constant equals R is equal to m me to the power of 4 over 8 epsilon naught squared times c. Okay, when we find out the reduced mass, this m is changed. We substitute this m, we replace it with u, which is the reduced mass of the atom. Scientists have found out that both proton, which is the components of the nucleus, and the electron revolve around the common center of mass. This actually give rise to a 0.1% deviation of the measured experiment. So here is the nucleus, we can say the proton. Here it is revolving over here. We can, and here is the electron. We give it here a red color. This is the electron. Okay, using, this is known as the distance, this is the radius r, this is the radius r, which is the separation distance between the electron and the nucleus. This is the common center of mass. They both revolve around it. Okay, and this is the revolution of the electron. Okay, here's another color. This is known as Rn. Make it better, capital N. And this is the Re, which is the distance between the electron and the center of mass. And this is R. Okay, we'll use the center of mass equation. X center of mass is equal to m1x plus m2x2 plus mnxn divided by summation n is equal to 1 to capital N of m n. Okay, and the center of mass will use this. We will use this is the y-axis, this is the x-axis, as the center of mass is 0, which is equal to m n, which is the mass of the nucleus, times negative r n plus m e, which is the mass of the electron, times r e, this is in the positive direction, divided by m n plus m e. So we can conclude that m n r n is equal to m e r e. Using this information, we can erase this. First of all, we're gonna erase this. Okay, and we're writing m n r n is equal to m e r e. As we have said earlier, we will change the new axis, this is the new axis. We'll choose another color here. This is the new axis to neglect the effect of the mass of the neutron. So this is the new axis, we call it y prime, and this is x prime. Okay, using this, so x, which is the center of mass in the x-axis, is equal to Rn, is Rn, units from the origin of the new axis. This is equal to, okay, mass of the electron times R divided by m n plus m e, right? And you know that R is equal to Rn plus Re. Yes, yes. So we can say that Rn is equal to me into Rn plus Re. Divide this by mn plus me. So you can say that Rn mn plus Rn me expand is equal to me Rn plus me Re. We can cancel here. Rn and me is cancelled with Rn and me. So you can say that also you can, sorry for the mistake here, this is correct, here is the problem. We substitute from the first equation m and Rn, which is me into me times R over what? Over mn plus me. No need to, okay, that's equal to E times RE, which is R minus Rn. So we can say that this cancelled, ME cancelled ME. We can say that MNR divided by MN plus ME is equal to R minus Rn. You see that Mn over Mn plus Me is equal to 1 minus Rn over R. Yes, okay. And if we neglect the cancellation here, so Mn Me over Mn plus Me is equal to Me, to big bracket, 1 minus Rn over R. Right. So Mn times Me divided by Mn plus Me, this is known as the reduced mass. So you can define that the reduced mass is the mass of the electron times 1 minus the Rn, which is the separation distance between the nucleus and the common center of mass, divided by R, which is the separation distance between the electron and the nucleus. So this formula is correct. I just multiplied this formula by Me to define the reduced mass. This number is just a number. To get the reduced mass, I must multiply by a mass, because the reduced mass must have units in kilogram. So I must multiply by the mass of the electron in order to get a unit. I multiplied here by the mass of the electron in order to get a unit. Okay, this applies for all other factors other than modern physics can be applied in real life. This is similar to resistors connected in parallel. If you notice that here, I will explain it in a minute here. Okay. So I've recently defined the reduced mass to be Mn, which is the mass of the nucleus, times Me divided by the product of these two masses. This can also be written as 1 over Mn plus 1 over Me is equal to 1 over mu. You can notice that this equation is similar to 1 over R is equal to 1 over R1 plus 1 over R2. This is similar to two resistors connected in parallel. This is R1 and this is R2. So if I have two masses instead, one of them, this is exactly equivalent to have two masses. This is the mass of the neutron, this is the mass of the electron. They are both, I just flipped this 90 degrees. This is the mass of the neutron here, and this is the mass of the electron here. They are both in parallel to each other. In order to find the reduced mass, why this is reduced? Because I want to find the combined, instead of finding the combined mass, I'm finding the reduced mass, the real mass, the reduced mass. Why they are reduced? Because if you notice here, both resistors R1 and equal R2, the total resistors here are is equal to half R1, or you can say is equal to half R2. So this R is considered as the reduced mass, the combined, the total. This total is reduced. Instead of saying R1 plus R2, or just, which is it, or you can say R1 plus R1 to R1. I'm just saying it is half R1 or half R2. So this is considered to be as being reduced. Okay, I hope you had so much benefit from this lecture, and goodbye.